example number 1, it says that I wanted to find what is the reaction at C. Remember, it's a reaction at support C, and in order to do that, we know that there's a support CY. So the step 1 is to release this support by applying a Müller-Breslau principle, which means that it's a guided ruler, and you are going to, let me draw clearly. Okay, you're going to apply a guided ruler for this support, and then you're going to move by one distance. And if you do that, if you move this, it will go up. Okay, so it'll move by a unit displacement. Now you, because it has to be a straight line, if you happens to say, okay, this is how you draw, remember, you are violating one of the criteria. What's that one? You are bending the beam here. This beam is bending if you draw in this way. So you are violating one of the criteria. That means this is not the influence line of the structure. That means you are doing wrong. So please keep that in mind, that you cannot draw like this way because you are bending this beam. Okay, so how do you do that? I mean, how do you draw? That means this one has to go up. That means if you draw a line, then it has to go up. Okay, and then once it go up, and then you can move this one up also, and then after this will go down, and then completed your deflected shape. Okay, so let's see, apply the criteria. I applied it. I released the constraint by applying a guided roller because I'm interested in finding the vertical reaction at C. So I applied it a guided roller and apply a unit load 1. and and did I break the beam? No, I did not break any beam at all except at the internal hinge. We know that we already mentioned that the internal hinge can move up, can move down, and can rotate. So that's why you can rotate this two internal hinge, because they are internal hinge. So they can move up or move down. In this case, this one move down, this one move up. They can do so because they are internal hinge. And look at the support. I did not move this support. I did not move this support. I didn't move this support. if you if you happen to draw from here, let's say you draw and you make it like this, and you complete it like this is also wrong. The reason it's wrong is because you are moving this support over here, which is again a violation of the criteria. So you cannot move the support, you cannot break or bend the beam except at the internal hinge. So your final influence line for this beam will be there, correspond to your deflection or deflected shape. So now we can draw the final deflected shape of this beam. And please remember that this is a determinate structure. That's why you'll see that all the line are straight line. And this value here will be equal to, 1. And also you can find what is the value here, you can find what is the value here, because you will know that you can find what is the theta here. And if you use tan theta will be equal to 1 divided by 10, and so you can find out here the value, which will be 14 into 10 theta, and that will give you 1.4. So this point will be equal to 1.4. And then for this point, all you have to do is use the similar triangle. I can use any triangle because I can find that this triangle and this triangle are similar. So I'm going to find here that, let's give this one h1. So I'm going to say that h1 divided by 4, which is my distance, this distance is 4, will be equal to 1 divided by 10. And so h1 will be equal to zero point 0.4, but here I will put minus 0.4 because this is anything down, anything below the initial beam structure will be negative, and anything above will be positive. Okay, so you find all the values of the point. Okay, so that's how you draw the reaction at C using all the criteria that I just mentioned. So make sure that you apply the roller, guided roller, because we're interested in vertical reaction, and then you apply a unit displacement, and then after you see the shape, the deflection shape or deflected shape, and make sure that you don't move the support at all. Like here you don't have to move the support, otherwise it'll be violation of the criteria. And because this is internal hinge, they can move up or down and they can rotate, and also all the deflection is straight line. Okay, so that's how you draw the vertical reaction at C. And now how do you draw the vertical reaction at A? We're going to follow the same procedure. We're going to put step 1, introduce a guided roller, and then move 1 unit displacement. So if you move a unit displacement, it's going to go up here, and then um, what you're going to do is, I'm just going to show you that if you have drawn, you said that okay, this will go up, okay, go straight line, and then you'll struggle, like, then after that what you're going to do is you are going to struggle here to keep it this, either it will go like this. Okay, in like you will think intuitively, you'll be thinking, oh, okay, this is how it should be, but again, this is wrong, because this is a determinate structure. So if it is a determinate structure, this is wrong, because this is either you are bending the beam, or the deflection is not straight line. So this is wrong. So now you have to think, okay, so this is not possible, so what is my next step? Then you have to redraw it again, and in this case you have only one option, that is it will be this, and then the whole thing will stay as straight line. So that means this will fully complete this only will rotate, and the whole thing will leave a straight line. And you can see that it cannot move because these two supports are there, so it will not allow to move. So that means only this part of the beam will be rotating. So your final influence line for vertical reaction at A will be so your final vertical reaction will be this. This will be your IL for AY or A, and this will be positive. So you say, okay, I don't understand again what it means. What do you mean by 0 here? Which means that in this case, if you're applying any load 1, you'll see that AY will be equal to 0. Which means that when the load is moving beyond B and C, the reaction at A will be equal to 0. And you can use equilibrium equation to verify that. Okay, so that's how you draw the influence line, and that's how you apply the Müller principle to draw the influence line for any response function, which means that it could be shear force, moment, or um, reaction. Okay, and then here we are interested to find the moment at midspan between C and D. So at midspan, which means in around 5, that means this will be um, 5 meter. This will be 5 meter. Okay, so Mueller principle said that you have to release that restraint or the constraint. So here the constraint, there is a moment initially. Now you have to release it by introducing a internal the hinge, and then you rotate this um, clockwise, and this will be counterclockwise, because we always follow the positive sign convention. So in this case, we are going to see that if this beam rotate counterclockwise, then it has to be rotating in this way, because that's how you rotate clockwise, and make sure that you are not breaking any beam. So this has to rotate clockwise. Let's say that will be a theta 1. So it will be rotating counterclockwise. Sorry, this beam will rotate counterclockwise, and you'll see that this is possible. Because why? Because this is internal hinge, it can move up or down and can rotate, and we did not remove the support, and all the deflections are straight line. So that means that is possible. And let's see for the next next beam section. And so if this beam is going to rotate this DE, this beam, this one at the midpoint, this beam will have to rotate clockwise. So if we have to rotate clockwise, then it'll have to go this way. Okay, so that's how it will rotate, and this will rotate by theta 2. So you'll see that this beam rotated by counterclockwise, and this beam section will rotate uh, clockwise. And this, if you extended this line, this whole thing will rotate equal to 1 unit rotation, and that will be 1 radian. But we already know that if this is A and this is B, then this point will be AB divided A plus B, and that will be 5 into 5, 25, divided by 10 will be 2.5. So you'll see that theta 1 plus theta 2 must be equal to 1. Okay. And also now you can find this order 2 point using the similar triangle, or by using tan theta. And now let's see apply. So this is where we apply the internal hinge. We move it clockwise. We did not move the support at all, and this is internal hinge. It can rotate and move up or down. So finally we can draw now your influence line for the whole beam. For the moment at midpoint between C and D. Okay, so anything below will be negative and anything above will be positive. So this will be IL for your moment. So that's how we applied the Müller-Breslau principle to construct an influence line for a determinate structure. So I hope that is clear how to draw the influence line for any beam. So now you can apply for any beam structure as long as it's determinate using this criteria.